Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge for February. So the problem says that we get a list of ideas that presents a list of names that we are going to use for naming a company. And basically the process is to take two distinct names from this list of ideas. Let's call them idea A and idea B. And what we want is to swap the first letters of these two words with each other. Okay, so for example, with coffee and donuts, we want to swap C and D. Okay, so this, for example, becomes Duffy and this becomes Conas, right? And if the names that once we do the swap, if the two names, new names, are not in the original list, then we want to concatenate them and use, that is considered a valid company name, right? And so, of course, it can be ideas A, ideas B, but also ideas B, ideas B. So, for example, here, if we do D, Duffy, and Conuts, both are not in the ideas array, so both are valid. So we can concatenate it with Duffy, Conuts, and then we can do the reverse, Conuts, Duffy. And so we have two valid names, right? And so the goal of the problem is to return the number of distinct, so unique, valid names that we can get. So for example, here, if you take a look at the example, we can, as I said, from this here, we can switch the letters, right? And so we get Duffy, Conuts. Similarly, donuts, coffee, right? So just the reverse, we will get the reverse. And you can try the other examples and just see for yourself. However, in some cases, it doesn't work. So for example, coffee and time here, if we switch, we have toffee and Sime, or whatever you want to pronounce it, but toffee is already in the list, so this is not a valid swap. Okay, so yeah, you can have non-valid swaps. So that's the idea. Now in terms of constraint, we have 10 to the power of 4 here, and number of ideas is 10. So of course there is a brute force solution where you will just take all the possible pairs and just check, right? But that would be O(n) squared, and we have 10 to the power of 4, so that won't pass, because 10 to the power of 4 to the power of 2 is going to be too big, right? But what will help us here is the fact that we only have lowercase English letters in the ideas names here, and this basically means that you only have 26 possible variations for the first letter. So that's something that we should use here to arrive at a solution. So let's see how we can solve it. So a couple of observations that we can make here. So the first observation is that if you have let's say if you have two ideas or two names with the same letter, the same first letter, let's say time and toffee, right? So already looking at these two, you know that it's not possible to get a valid name from them, right? Because if you swap, well, it's the same letter, so if you swap time, this one with this one, you will get the same one, and this one is already in ideas, right? And so basically from this we can say, if same letter or same first letter between the two words, between pairs, then basically not possible to get a valid one. Okay, so that's the first observation. Let's move it down here a little bit. Now another observation is that if you have the same suffix, so not the same first letter, but just the same the rest. So here, let's say we have the first one toffee, and let's grab the second one, which is coffee, right? So if we take a look at these two here, again, same problem we have, right? Because if you swap, let's say you swap, then you would just get coffee here and you would get toffee here, and both, this is the same, we just flipped them, right? So both exist. And so basically here, either first letter or same, let's call it suffix, okay? Then it's not possible. So that's our second observation here. Okay, so with these two observations, actually, we can arrive at a solution. So what we can do, we can first, let's just handle for the first character. So what this tells us, basically, if the first letter is the same, we know it's not possible to pair them. So what this tells us is maybe let's just group by letter, right? Because if we group by letters, then for each group, right, we don't need to compare between the group itself. We just need to inside the group itself, we don't need to compare because we know there won't be any valid names. We can just compare between the groups, right? And so that's exactly the idea here. And the groups are going to be by just the first letter, because that's exactly where it's going to be only possible if the first letter is different, right? So for that, then we can have C. For example, here we have D and we have T. So in this case, C is going to have coffee. Let's do this here. So C is going to have coffee and just that. And D is going to have donuts. And then T is going to have time and toffee, right? Okay, so now how do we handle this suffix thing? So what we can do is, first, once we have this list here, we can, for each one of them, for each of these letters, we can just check what are all the possible pairing that we can get from it. Of course, excluding those that have the same suffix. Okay? And so what that would mean, basically, we know that this is, the key is a letter, and we know that we only have lowercase English letters. So this here is going to be just at most, the number of keys is going to be at most 26, because that's the number of lowercase possible letters, right? And so instead of like going through all the words, we have the group keys. Instead of going through the group keys, we can just go through the range of 26 to get all the lowercase letters, right? And then for each between the groups, we only need to do the check between the groups. So for example, for C, we will check for all the groups, D, E, F, G, H, all the group. For A, we'll check for B, C, D. So for each letter, we'll check for all of the following letters, right? If that makes sense. So for example, for A, let's just check for all the groups that have from B to the end of the alphabet. For B, we check from C to the end of the alphabet. Now you may say, why not just for A, check all of them, for B, check A, C, D, E, F. We can do that, but just to avoid, if you do that, then just remember, it's going to take more time, right? Because, for example, for E, we will do all those before. But instead of doing that, we can just, for each letter, do only those after it. And when we are doing the calculation, consider both variations. So for example, let's say for coffee and donuts. So for example, for coffee and donuts, we have two possible company names, right? When we swap, we'll get Duffy and Conuts. And so the number of company names we can make are Duffy Conuts. And then we can make Conuts Duffy, right? And so instead of like when we are doing C, so when we are doing C, we go through to D. But when we are doing D, instead of going back and doing C, let's just count when we are doing C, let's just count both variations. And so that would be just taking all the possible combinations for C and just multiplying by 2, because we will do both combinations, right? So I hope that makes sense. So we'll need to multiply by 2, because we are going to do just, for each letter, we are going to do only the subsequent ones. Okay, and so the question becomes, how do we know how many we have here, right? Right. Well, we can just take the length of the set for that character, of the number of words that start with that character, right? So let's call these A, let's call this I, so it's I. So it's just going to be the length of the sets of the words that start with that character, okay? And then we need to multiply by the length of the second character. So we do I, and then we do for J in the range from I plus 1. That's what I said here to 26. That's what I said here. So for A is index 0. For A, we'll start J from 1. For C, so 1, 2, which is index 2, we'll start only J only from D. Because for each one, we'll go only through the subsequent ones. And so this is going to be length of J. Okay? So this is going to be how many valid company names we can make. So this is what we are going to add to our total count, except there is one thing that we didn't handle here. And that one thing is when they have the same suffix. So how do we handle that? So one thing you will realize is you actually don't need for the sets here. So this is, by the way, is going to be a set of all the words because we don't need them duplicated. It doesn't make sense. So it's going to be, and also the problem says that the names are unique anyway. So we can use a set here. So each of these is going to be a set. So one thing you'll realize is actually we don't need the first letter. We already have it as the key here. And so let's just store only the suffix starting from the first letter. Starting from the second letter, I mean. Okay, so this would be just I'm, and this would be just Ophi, right? And so now we can identify those that have the same suffix. How do we do that? So so what we are doing is comparing the content of two groups. So basically this one with this one with this one, right? And this one with this one, right? So that's what we are doing. But if two here have the same suffix, then we will never get a new valid name from them. So we should skip those that have the same suffix. How do we identify those that have the same suffix then? It should be pretty easy to do. Let's see how we do it. We can just use set intersections because this is a set. So we can just do the set intersection between the elements in the two groups, and that will give us what we need to remove, right? And so to do that, well, we can just, for the intersection count, let me just move this down. So let's call this intersection. So this is basically would be for the same suffix case. It's going to be just the intersection of the words of the suffix for the one that starts with the first letter and the one that starts with the second letter. By the way, A is going to be just this. This is A. Okay, so this is the intersection, which means it's basically going to be the words that have the same suffix that starts with I, between those that start with I and those that start with J. And so what we need to remove is just the length, which is the intersection count, is going to be just the length of this, right? So just the length of this. Okay. And now we need to change this here to just use that count. So it's going to be, the count is going to be 2 multiplied by the length intersection count. Let's just make this shorter and call it IC. Okay, so it's going to be 2 multiplied by the length of AI minus the intersection count, and then multiplied by the length of AG minus the intersection count, okay? And that should be what we need to add, and that's pretty much the result here. Yeah, so once we remove the intersection, this is what we need to add to the overall count, and that's pretty much the solution here. So what did we do? So we will need to do the first pass to just create this groups here, right? Where each letter is going to be the start of all the words, the suffix that we have in the set, which is the value. So the first letter is the key, the values are the suffix for all the words that start with that letter. Okay? And now, because we know inside the same values there will be no valid pairing because they have the same start, and we already established that first letter, if it's the same, it's not possible to get a valid name. Okay? And now we know that the only valid names are going to be groupings between the groups, right? Between these different sets, right? And so we just go through all the possible groups by just going through all the possible alphabet letters, because we know this is going to be only contained of the alphabet letters. Okay? And here, because we are doing multiplied by 2 to account for the 2 variations, for each one we just need to go from I. For the second one we just need to go from I plus 1 to the end, because we already counted 0 to I plus 1. Okay? And then once we do that, we can just count the intersection to remove those that have the same suffix, because again, from those we won't get a valid name. And then from there we add to the total count, and that should be it. Now, in terms of time complexity, for the first loop to just do the grouping, that's just going to be the length of ideas, right? So it's just going to be O of n. For this loop here, right, we are doing just 2 loops that are each 26. So it's going to be 26 squared. So overall time is just going to be O of n, right, plus 26 squared. So overall is just O of n time. So from O of n squared solution, we can do actually just an O of n solution. Okay, and so that's pretty much the idea for this problem. Now let's just code it and make sure it passes test cases. Okay, so let's implement this solution that we just saw in the overview. So the first thing we need to do is we need to just create the groups. Let's call them groups actually, because that's easier. And it's going to be a set, right? That's the value. And we just need it for all the lowercase English letters, because those are the only characters we have, right? And so we are going through the ideas. And what we said here is that the key is going to be the first letter, and the value is going to be a set of suffixes for ideas that start with that key, right? And so the groups, so we need, since we made this be just a range, we need to convert the character, the first character, to an index, right? And so to convert the character to a value index, we can just do OR here and subtract A. And this, for example, for A, it gives us 0. For B, it gives us 1. For C, it gives us 2. And you get the idea. And so this is going to be our key. And so that's going to be the key here. And we want to add to the set the suffix. And so it's going to be idea 1. Okay? And now we just start counting. So our count, and we return that. And we said we want to go through the alphabet for lowercase alphabet, so indices, of course. And since we said we will count both the variations, right? So here for J, we just need to start from I plus 1, because for each iteration, right, with X and Y words, we will both count when you replace the first letter. When you swap the first letter, we will count both X, Y and Y, X concatenation. And so we don't need to do it again. And so that's why we are starting with I plus 1 here. And so first we want to get the intersection that we want to remove. So these basically, because if same suffix, right, can't be valid, which means we want to remove those that have same suffix. Okay, and so to do that, same suffix is just going to be the groups that start with the letter at index I, and those that the intersection of those and those that start at J. So in the intersection of those two sets means they have the same suffix value, and so basically they have the same suffix, right? And so we want to get the length of that. So we said let's call it intersection count, and so it's just going to be the length of the intersection. And what we want to add, so the the pairs that we have are the length of the groups that have I, right, multiplied by those that have group J, because those are the two pairs that we can, so this is the number of pairs that we can make, but then we need to multiply by 2 to account for these two variations, right? And then on top of that, we need to remove those that are the same suffix. We need to remove them from each one because you have the same suffix in both. That's why you have this, right? So if you have two sets, one is 1, 2, and the other one is also 1, 2, right? This intersection is just going to be 1, 2, right? So let's say maybe you have some other values here, right? And some other values here. Same thing for the second set, right? The intersection is going to just give you 1, 2. So, and you need to remove those two values from both the first one and the second one, right? Because they exist in both. That's why it's an intersection, right? So that's why we remove them from both here, okay? And this is what the total is, this is what we need to remove. Sorry, the total is the number of distinct names, because yeah, this is the valid names that we counted. And so now this should be it. So if we run it, so this is actually idea, the first letter, so idea 0. And looks like there's a problem here because this is a value and this is the length. We are removing from the length. So this is the length actually, and we need this, okay? Okay, that looks good. Let's submit. And this passes our test cases, okay? Yeah, and this solution, as I said, is here we have O(n) and here of 26 squared. So overall, it's roughly of n, right? Yeah, so that's pretty much it for today's problem. Please like and subscribe and see you on the next one. Bye.